and welcome everyone to the Open Humans community call. We have a bunch of people here. It's great, and new faces and familiar ones. The format for these calls is to start with a very brief sort of hello, something about you, and then pass the ball to another person who hasn't spoken yet. Please do not take up more than a sentence or two, or I'll just like jump in and say, let's move it along. But do say if there's something that you'd like to discuss later during the meeting. And then based on how many people bring up topics that they wanted to ask about or share with others, we'll try to make sure time is apportioned correctly. And so with that, hello, I'm Mad. I'm Executive Director of Open Humans. Yeah, I wear a lot of hats, but start by leading the call. And with that, I will pass the ball to Gary. I'll pass the ball to you.
Hi, I'm Gary, and I'm the founder of Quantified Self and a board member of Open Humans and a participant in Quantified Flu.
And you have to pass the ball.
Sorry, I passed the ball to Kate.
Hey, it's Kate Waka. I'm a Quality of Life Technologist Lab leader at University of Geneva and Copenhagen, a computer scientist, and I pass the ball to Christopher Vensink.
Yes, hi everyone. I'm also a computer scientist from Osnabrück in Germany, and yeah, I'm also doing Quantified Self for a few years now, and yeah, happy to see you all again. And I pass the ball to Bastian.
Okay, hey everyone, I'm Bastian. I'm the Director of Research for Open Humans and a Research Fellow at the CRI in Paris, and have been doing self-tracking for many, many years and working on it. And I pass the ball on to Richard.
I'm Richard Sprague. I'm sheltering in place here in Seattle. Just a longtime amateur data collector about myself. And I pass the ball to Melvin.
Yeah, I'm Melvin Fribourg. I am a student at the Life Science Bachelor of the Center for Research and Interdisciplinary of Paris, and I pass the ball to Ilona.
Hi everyone, so I'm Ilona, and yes, I'm at the Life Sciences Bachelor too at the CRI of Paris. And I pass the ball to, I don't know who did not speak. Well,
I think Danny hasn't spoken, and Justin.
Yeah.
Yeah, hi, my name is Danny, and I'm a PhD candidate right now working on health data commons, and yeah, I come from sociology and mix between sociology and anthropology. Yeah, and now, last but not least, Justin.
Thanks, Danny. I'm a computer scientist as well. I'm with UVM and now working for an automation and cybersecurity company. So I'm just hoping to help out a little bit and learn more about how the biomed community kind of works together to accomplish their goals.
Great. So in terms of what we want to talk about today, I think, Christopher, you didn't mention it, but you did put in the notes something that you had wanted to share. Do you still want to share something? Are you hoping to share that? Something about video motion.
Yes, but it's I think it's pretty short.
Okay.
So yes.
Great. And the other big thing I think that we wanted to talk about was quantified flu updates. Quantified, as a very quick background, Quantified Flu is a project that we started that arose kind of out of the quantified self and self-research discussions that folks were having, wondering if wearable data could help inform people about warning or understanding that they're getting sick, and what relationship that has with symptoms. And so Quantified Flu is a project that helps people try to visualize that data and also collect ongoing symptom tracking. And I think that two of the folks attending are students working with Bastian that have some stuff to share, and that we also have some other updates to the site. that we've made and stuff that we're working on, and of course open discussion about like what should Quantified Flu be doing. Like this is something where we want that we consider this a very participatory project, since it arose from people in this discussion community being interested in the question. And so what should we be doing? Another thing I like to emphasize always is that quantified flu is not epidemiology. It's really about exploring how to create that individual value for the data. I know that there's like big academic projects trying to do epidemiology, and like this is, but I firmly believe that when you have highly engaged people, a smaller number of people can do very powerful things that were not possible when you had like a large number of shallow contributions. So with that, I'd like to pass it to Bastian to share quantified flu stuff.
Yeah, I mean, I will basically just want to give it over to Ilona and Melvin, but just for giving a bit of context, Ilona and Melvin are part of a project which is called SCORE at our institute, where undergrad students get some time to spend with researchers to get some first-hand research experience instead of just doing regular courses and things. And Ilona and I have been working on self-tracking experiments already last year about the different influences of mood, and I can put in a link to the report Ilona and her fellow students wrote last year about this. And as part of this group now, Melvin and Ilona have started working, I think, exactly 2 weeks ago with me, and have been analyzing all the data in Quantified Flu, both the wearable data as well as the symptom reports a bit. And I wanted to give them opportunity here to share what they found out so far and the visualizations they made. And I think we can see from this what new features we might actually want to include into the main site based on their preliminary results already. And Ilona and Melvin, I give you the screen. Feel free to share and give us updates.
Okay, so I'm going to share my screen, but you have also the link in the docs that Bastian shared me. So maybe you can click on if you want to see. And so, yeah. Well, I have like host disabled, attendee screen sharing.
I'm seeing, yeah, here we are. Okay, I fixed it. There's new security settings in Zoom.
Okay,
okay.
Sorry.
No, it should work now.
So Firefox. Yeah. Well, it's not really working.
So can you try again to share your screen? Because I know it was disabled initially.
Okay.
And I'm going to say hi briefly to Dave and Beck. Welcome.
Yes, now it works.
It should be great. Can you see it?
Yeah, we can see it.
Perfect. So, Melvin?
Okay, so yeah, during this currently in a kind of an internship for 3 weeks with Bastian, we plan to respond to a precise question, which is from Oura Ring and Fitbit wearable data. Can we find a pattern by looking at temperature or heart rate graphs, which could be correlated to a sickness event? So to make our analysis and answer to this question, we used all the different data provided by the Quantified Flu website, which are mainly heart rate record, temperature, and symptoms. Here is the representation of the data repartition that we used. As we can see, there are 2 types of data, the ongoing and the retrospective data. This graph also shows the repartition of the variables type used in those data. So there are 2 different types of variable, the Fitbit one and the Oura Ring one.
Okay, then so one of the first works we made was generating a heat map that correlates symptoms. So we created a spreadsheet where we wrote down all the symptoms reports of the ongoing symptom data folder. And for instance, if someone for the same date indicated anosmia and body ache, we wrote down +1 in the intersection between anosmia and body ache. And after, we clustered our data by symptoms, and so it allows us to class in a hierarchical way all the symptoms from our dataset. So as you can see, for instance, the intersection between runny nose and headache is like in dark red, so they are really correlated. However, for nausea and wet coat, for instance, is dark blue, so they are not really related. So we made that for all the symptoms reported by all the people from the Quantified Flu website.
So we worked on many representation in order to compare the rings and Fitbit wearables. The main thing that we want to analyze was to know if there is if there are any differences between the heart rate captured by those two different variables. So to do so, Bastian suggested using the resting heart rate per night because it will be more interesting and closely related to the variables. As we can see in all those graphs, the variation of the resting heart between those two variables is calculated with the minimum heart rate value captured by the Fitbit variables minus the minimum heart rate value captured by the Waring variable. And they're pretty much close, even if sometimes we can see some big peaks and some big differences. From those previous observation, we calculated the percentage of similarity of the resting heart rate on the slide. On this slide, we can see that the Waring and the Fitbit variables have a percentage of 94 percent. However, we have to take in consideration the fact that we are only treating a few files for the retrospective data, so we can conclude in a proper way.
So after doing all this analysis, which is a big step, we generated also different graph of the temperature and heart rate according to the wearables per person. So the dotted line that you can see around January the 1st represents the date of the sickness event. So as we can see, there is a peak like around the sickness events for the temperature and the heart rate too. But however, we cannot be sure of that observation because sometimes we can also observe high peaks too without sickness events which are correlated, like around December the 15th. Then after we wanted to visualize a pattern around the sickness event, and Bastian suggested us to combine all the graphs in a unique one and scale them on the same fake date, like sickness date, in order to be able to compare them. And so we made one graph per type of variable. So here it is for the temperature by the Oura Ring wearable. And so we can see one interesting thing, which is that around the sickness date, we have many peaks for all the different files. But however, we cannot conclude in a precise way because we have many lines. So because it was not really clear, we represented the average pace by using the geom_smooth function in our studio. And so the geom_smooth allows us to represent the average, so the blue line, and also the repartition of the data, which is the gray zone around the blue line. And so as we can see, for the temperature, there is something really clear is that at the same time as the sickness events, we have a really high peak. So we can say that those two events can be correlated. We did also the same thing for the heart rates from first the Oura Sleep wearable, and we can see also a peak around the sickness event date. So it's really in the same conclusion of the previous figure we made. However, for the Fitbit, we can see really nothing which is symbolizing the sickness event. So So really our results are like compromised by the number of data we are using, and we cannot conclude in a precise way from these two observations.
So for the end of the week, which is also the end of our project, we are planning to approach the ongoing data symptoms folder by generating graphs of the heart rate and temperature for each person. And we'll also compare all the graphs that we have in order to deduce a sickness correlated pattern. And this pattern will allow us to respond to all problematic. Thanks for your attention, everyone.
I think you already answered one of the questions I already had, which was when I'm looking at the symptom correlations, I was really curious about how that breaks down for the individual. Although I'm not sure if the final slide indicated that. But yeah, that's something I'm curious about, because like on the whole, symptoms are correlated within the population, but maybe those graphs look different in each person. Were there any thoughts?
How many events per person we even have in order to make statistics? Do you have? It's a question. How many events per person at max you have? Maximum times when they got sick or reported.
Do you mean
symptoms?
like for the retrospective data analysis?
Yeah.
I'm looking this up right now. It's on the site, right?
No.
I can answer this. I think it's given that you have 6 things in total, and I know I have put in 3, so I think the maximum is 3.
I see. Yeah. No, it's just, no, I very much appreciate your efforts. It looks like we really need more data overall.
I think this
Yes.
this points to how limiting it is to try to do retrospective analyses and engage people to try to remember when they got sick and then use that data. And are there thoughts about taking the prospective data that people have been doing and trying to use that? Maybe I'm asking Bastian because
Yes, I think this was the point on the last slide. Actually, what's left for this week is looking into the ongoing symptom reports and the wearable data. But Gary, I saw you had raised a hand. I think you had a question as well.
Yes, I have 2 questions. One is, are the slides available? Because I was thinking about them and I want to look at them again. And then I have another question.
The link is in the notes document.
Okay, great. Thank you. And the other question is, in Ilona and Melvin, in the research, is there any conclusion that you feel confident in? I think it's very useful to see, like, there's a lot of noise in this data and there's not that much data. So very interesting that the Fitbit and Aura don't, give you the same answer, at least in one of the slides. But in exploring all around the terrain, was there anything that really jumped out at you as, okay, I feel confident about this?
Personally, no. I never felt confident about something.
Yeah, me neither.
So what I found very impressive is, even though it's only 6 sickness events, that the temperature and resting heart rate, at least in the Aura case, and seems to be pretty consistent. Like just looking at the graphs, there seems to be a consistent increase, at least in resting heart rate, even if it's now again more on a population level is like a lot to say with like at max 4 people participating in this, given how much data I have given. But at the same time, it seems to me that there's some kind of consistent signal which might like be super noisy for the individual, as we've seen. But once you start pooling it and put it on the same timeline by just shifting the dates so that you can compare them, there seems to be a good, interesting signal that only 6 data sets already seem to show. This surprised me. I did not expect to see like that strong signal, let's say.
So to speak to the utility of resting heart rate, the temperature predicting resting heart rate change, what we're interested in is the converse statement. how often does a rise in resting heart rate correlate to that temperature, even on the individual scale of you, Bastian, in your 3 retrospective reports? And just looking at you, do we have a feeling for that, for how predictive resting heart rate would have been for the temperature?
I don't think we've looked into this at all so far. I guess like the one interesting confounding thing that I had looked into my own data into the past was just like how much you sleep, because the resting heart rate is taken as like the minimum measurement during sleep. And if you don't sleep enough, you never give your heart a chance to slow down as much, which looks like it's an increase in resting heart rate, but it's just maybe an artifact. And if you had slept more, it would have gone down more. So it's like, it would be interesting to see how much like a lack of sleep influences this as well.
If that's true, I mean, if it has a confounding effect, it should be included in sort of the data people use to try to interpret, right?
Yeah, I mean, at the same time, probably if you are falling sick, you sleep worse. So it's like, probably like it's less problematic because you, in any case, don't sleep well. And this is partially explaining it as well. So it's...
I have another question that's kind of like Gary's. Are there notebooks that is the code for creating the graphs something you're also hoping to share?
Yes, we made like a daily diary where we put everything inside so we can share it too. Like we're just explaining what we did. So.
Yeah, I think it'd be great to have a link to those or share those as well. That would be just in case anyone's curious and exploring it. I think we're leaving a moment here to see if anyone else has any other questions or ideas inspired by this.
Yeah, I have one. I think there are also other reasons for resting heart rate to increase. So for myself, I found that it increases after I did a lot of sports. So if I put a lot of strain on my body, I don't get that low resting heart rate in the night after that. So that could be one reason for the false spikes. Where you could think someone is sick, but he just did a lot of sports the day before. And so maybe it could help to look at more data like activity data. And if there was a lot of activity the day before, it could be related to that and not to a sickness event.
And another one that's well known is if you eat a lot of calories. So it seems to be pretty highly correlated with the amount of food you ate in the previous days. I know that's true for me and for a bunch of other people I've talked to.
Richard, what's the range of how much does it go up?
For me, I doubled the number. So I've been running an experiment the last couple of weeks where I doubled the number of calories I eat per day. So from about 2,000 to 4,000, and it goes up a good 20 points, 20 beats per minute.
Wow.
At first, I thought I maybe had the flu. Then I found out. Then on Twitter, somebody pointed out that no, that's a pretty common thing when you're eating a lot more.
Oh, wow. Okay, I'll just say for me, yeah.
Please go ahead, I will ask later.
I'll just say that for me, it goes maybe 3 to 5. No, maybe 3 points, 3, maybe 5 if it's really a late dinner with a lot of alcohol. Or like, I don't know, 2 glasses of wine for me is a lot of alcohol. So so it's very much confounding factor, yes. But I wanted to say something else. I would be very happy if you, Matt and Bastian, prepare like because we need more participants. We need more people. It's relatively easy to connect everything and daily answer daily emails and check the symptoms. So it looks like we could help with the campaign of getting more participants. Yes, and thank you.
Yeah, that would be great if we get more participants. Actually, Gary, Matt, and I just had like a brief call before this one about this, how we can get more people to participate. So that's definitely on our agenda. And I had just a question for Richard, like how hard is it to double your calorie intake? Like, do you have to like, how do you achieve doubling your calorie intake and how terrible do you feel while doing it?
Well, there's you can buy these high-calorie drinks that are made for people who are trying to gain weight, and you know, athletes often buy, you know, like whey powder or whatever. You know, I've always been a little bit on the thin side, and I've discovered the reason why is because I just eat fewer calories than I should, I guess. But when I've been carefully tracking things, in order to be able to double my weight, or in the number of calories, it basically just means I have to eat a lot more. So I'm eating all day long.
Thanks. I had a hardware question for the team. Oh, can you guys hear me?
Yeah.
Yeah.
Okay. So based on some of the graphs comparing the heart rate derived from the Fitbit versus the Oura Ring, slide number 9, where you have both of the graphs of the heart rates next to each other, look like you were able to see a heart rate change relative to the day they got sick on the Oura device and not the Fitbit device. Was that right?
Yep, that's it. Yeah.
Mm-hmm. Do you think that that might be because the Oura Ring takes a heart rate from like a more distal part of the body on the finger as opposed to the wrist? Or can you comment on if that might be a hardware thing or more of a software and algorithms aspect of how the two different platforms process that data?
Like we compare on the slide number 5, there is a huge similarity between those two types of recording data. So we personally, I don't think that that is the software is the cause of this variation.
Mm-hmm. So it's probably more of a hardware positioning aspect of it. Do you think that it might be the hardware or the positioning more? So saying, is it a different type of sensor, or is it that it's on the finger as opposed to the wrist, and the finger's just you can derive more insight from that location?
Yeah, I think that's it. Yeah.
All right, thank you.
I think it's also worth noting that a lot of the data was from one person, so it might be some people are wearing things in certain ways, and it might not always be true. So it's hard to know.
Variables there. Absolutely. Is there any
maybe more generally, like I feel at least that like you cannot comfortably wear your Fitbit too snug during the night for sleeping. So probably there's like more movement of the device itself going on compared to the Oura, where you have no choice for making it looser or more tight because it's the size it is and it continuously stays in one place. So I think this might also be part of the reason.
Do you know if there's any literature on basically analyzing the efficacy of these locations on the body, as well as actually the devices themselves? Did you find anything interesting?
I feel like if anyone would know, it would be Kate. I'm just guessing. There might be others folks that would know.
Thank you very much for having trust in me. The gold standard for this would be the chest. I mean, the chest strap as closest to the ECG, and the location. I don't know if Oura Ring was. See, I don't remember. We've been looking at the papers where we were, and that's also what we discussed here. The most accurate these devices are for resting heart rate, and at night we are not moving and not exercising, hopefully, and doing other things. So, and also the papers were showing, but I don't remember exactly how this paper. If imagining the chest strap would be the gold standard, what was against the chest strap, what was Oura versus Fitbit, and how different were. I don't know. I don't remember this. If this paper even had Oura, I think it had Fitbits and other devices.
And other like optical wristband.
It might be that there's not much knowledge about the Oura or Ring in particular. Like there's a lot around wrist versus chest.
Yeah. But I just remember one forum post in the Quantified Self forum where someone was wearing 2 Oura Rings, one on the left hand and one on the right, and there was like a discrepancy between those even. So despite being the same device, just like the ring finger of the left hand, the ring finger of the right hand, and you like ended up having different temperature measurements and different resting heart rates and different everything. So
this is what happens when you have closed source feature extractors. You can't answer those questions. Yeah.
Well, I guess I'm not sure whether like an open source thing would actually be the solution. Maybe we just have to accept that all of these measurements are inherently noisy and there's not much we can do. I think that's
maybe
it might also speak to being aware of using your device consistently. Like, don't switch which finger it's on, that sort of thing, because then if you have any hope of figuring out signals within your own data.
Yeah, that's what I tried to get into. Where, like I say, like you wear the Fitbit, like one day you put it in like the third hole in the strap, and the other day you put it in the fourth, and all of a sudden it was more loose, and the resting heart rate goes up because it just wiggles around more during your sleep around your arms. So that's.
So I'll pipe up and say I'm a Fitbit user, and I haven't tried the Aura, but I think the devil is in the details too, in the data analysis, and some more data and also understanding context might help. I don't know if there's some outliers in there in terms of, so I think you can get a pretty clear picture of the reliability of your own device by watching your own data over time. And so I definitely see in some months of Fitbit resting heart rate, a very close consistency night to night. It for sure goes up 1 or 2 beats or down 1 or 2, sometimes as many as 3 or 4. So you're talking maybe, 8% of the total. And I have my suspicions about why that is. I definitely think that sometimes timing of the measurement, like, there's various kinds of, like you're saying, feature extraction that's going on inside these continuous measurements that account for that. But I don't see it varying a lot, even though, I'm not always wearing it in exactly the same way. So whether that actually signals sickness onset, this is all very unknown. But I do think for the most part, we can rely on some consistency in the wearables data around resting heart rate.
So they've done a pretty good job at like normalizing between these kinds of variables, but still sketched out on the kinds of design decisions that they made, and not knowing exactly like what they might have done.
Well, one thing is for sure, this is important to note that that's a synthetic measure in some way, this resting heart rate measure, and I actually think that Aura and Fitbit, there's some, I can look it up, but there's some knowledge of how it's done differently. Like, I could be wrong about this, but I have a memory of learning that Fitbit actually looks at your waking time in some way to understand, and then goes backwards in a sense from your waking time to determine when to take the period in which they're averaging. But I'm not positive about that, but there is definitely some synthetic kind of analysis work.
Some kind of normalization techniques that they may be taking retroactively.
So, Bastian, do you want to talk about other quantified flu stuff? Because I know there's other updates.
I think, yeah, let me see, what else do we have an update? So there is the minor changes that we discussed last week of how to find the buttons for reporting symptoms. And maybe I just quickly share my screen. That's maybe the way to do it. If I find the button, that is.
You're now host now. I just passed that off to Bastian because I might have to leave early. Which means you should have like a security button and all of that stuff now.
Oh yeah, I have like a lot of new buttons, which is why I couldn't find the share screen button.
My fault.
Okay, so I think you should see the screen with our notes right now. And well, one update, which I hope Basil, who is an intern with me as well, who's doing a master's in computer science, actually created, but he's sick unfortunately today and could not present, is the first visualization of the ongoing heat of the symptom reports in this heat map fashion. So if you have your data of the symptom reports, either any public data or your private one, it will load this nice little heat map showing you over the time the symptoms you have and all the comments you write. And I picked one which is interesting because this person actually has like a lot of interesting comments about being an essential worker and getting access to a COVID test and then actually getting tested and received a negative result and says, but this was most likely a false negative, and I actually think I had COVID. So you can now, the public data, each public data set has one of those, so you can actually start exploring the data in a bit more detail compared to the symptom report tables. And the other thing that we made, it's really the most minor thing, is that we switched around the visualizing past events to focus more on the ongoing symptom reports and make this button nice, big and bright so that everyone hopefully can now find the symptom report, because some people reported finding it hard to see how to do it outside the emails because the button was the same color as everything else. And I think that's all about quantified flu that we have new. There is ongoing work. The Garmin integration for Garmin wearables is being developed, and the API is a nightmare. I know from Carolina, who's working on it. And she's still fighting it and trying to figure out when it does not actually report data and how to figure out how long people had their device and how much historic data we can get. But I hope that in the course of this week, hopefully we have like a working version of this available as well. And I think that's all quantified flu for today.
I want to add that I am planning to keep working. I started work on making it able to edit and potentially delete past symptom reports, and maybe making it possible for people to make past symptom reports like from previous dates when they missed those dates, but if they had a spreadsheet somewhere. And part of it is just like sort of bugginess in the interface where I know I've accidentally entered something in twice or like accidentally clicked a slider that I didn't mean to click. So that's also on the roadmap, hopefully in the next week.
And then I'll pipe up and say from our call earlier, I took on the job of just getting the word out a little bit more about quantified flu. It's clear that more participants would be good. I just put a little quantified flu hashtag in our chat. So if you have a chance to talk about quantified flu or present it, do. And then if you use the hashtag, then I'm going to be kind of following that. So you don't have to let me know, but it's nice to be able to figure out if we get more signups where they might have come from.
And also, if you have any ideas where people are talking about symptom tracking and where people might be interested in quantified flu, I think let us know, especially Gary, who's doing some research into where to share it now.
And I'm going to give a talk to health informatics team of, I don't know, 70 medical students. I invited to give a talk about our health informatics aspect, right? And I wanted to mention that I would love to get some materials from you and give you full credit, and also say that this is something which has potential. Yes. That will be in a month. So we'll get back to this.
So is that a month from today, or like in about a month from now?
Yeah, 25th, yeah.
Yeah, it'd be great to work with you to help figure out what you can share. And
yeah, we'll make a slide or something.
Perfect.
Are you collecting?
I'm going to help. It's not that I'm just requesting. Yes.
Are you collecting information about whether people are taking supplements like D3, zinc and glucotinate, C, magnesium citrate, and so on?
The short answer is no, but we had also, when Gary met and I met earlier, discussed a bit of what additional information to track and doing maybe one-off questionnaires as well about things like supplements or whatever other information people might be able to provide, which might be useful in analyzing the data. So I think this would be a potential thing we could include there.
Because I think it's very important that people are taking D3 and zinc, glucotinate, and so on and so forth, but those two in particular. And I'm amazed that people aren't advising that just as you are washing your hands and wearing masks, you should also be taking D3 and zinc. So I'm just amazed that nobody's really promoting that. How many people are taking D3 and zinc in this group? Raise your hands. Not only a few. I'm amazed. Okay.
How do you, Apple Health keeps track of things like that, like vitamin levels and stuff. I can't remember if the Open Humans uploader, does it also upload like nutrition information?
Not yet, but we can add it in the future. Now that we have a working version of the HealthKit exporter again, that should be hopefully.
Because if somebody already is using like Chronometer or one of the other apps that lets you upload that stuff, then you've got that data for free.
Yeah, that's a good idea.
Yeah, I think that the app, extending the app would be great. It's just like we've finally got it through and it's just doing heart rate, like resting heart rate plus heart rate. But obviously that could now be extended to other types of data. But it's really nice that you got it through the App Store eventually. Did you keep track of how many times that was, Bastian?
No, it was too many rejections to keep track of. But also, if anyone here is interested in contributing to it, it's written in React Native. So if anyone here is a React Native developer and wants to just do the extension and help out with it, the code is open source, and I can point you to the GitHub repository to just give it a try.
So do we want to call on Christopher to briefly share this is something completely different, I think, but to read from your note in the note document using the video to visualize pulse. And that sounded interesting, something you wanted to share with folks.
Okay, now I'm not muted anymore. Okay, yes, I can share my screen and shortly. It's just a video I made, and I tried to extract pulse from it. So I was doing some computation to magnify the very slight motion from the pulse. So I have to actually. So this is the original video. So it's playing now. So you can see much motion, maybe a little bit of pulse down here. And then I did some motion processing. And now I show you the processed video. And so now you can see pretty clearly, if you look down at the bottom, that you can see my pulse down here, which was only very slightly visible in the original video. And I got it actually from a paper. It's open source. They have contributed their code and stuff. It's written in MATLAB, and I was trying actually to achieve something similar to this, where you can really see like the whole face lighting up when the pulse is hitting, but I think I did it with a smartphone camera, and I was, I think, too much moving, and it was not artificial light, but normal ambient light and nothing fancy or something. So I will try to reproduce that with some polarized light, and also some infrared light maybe to get a bit deeper into the skin. So the algorithm is just doing, amplifying little color changes in the skin. And I think it's not actually enough in this video I took. So that's, I think, the reason it didn't work. So I think maybe it also relates a little bit to what was discussed earlier. So whether Oura or Fitbit is more accurate, or which reading position is more accurate. And I think reading position is not that crucial, because you can get a good pulse from everywhere. So also basically from the face, or from your toe, or basically anything. but I think it's crucial how it's processed actually. So yeah, even with such a weak signal, you can get a good pulse extraction if the processing is right. And I believe I had a number from a paper, and it was saying, I think the pulse signal in a normal wearable is about 2%. So all the rest is ambient lighting and like general perfusion and stuff, and not the pulse signal. And the pulse signal is around 2%. And if you do the camera-based pulse extraction, like they do it here, you are even, I think, 100 times lower than that. So you are at 0.002% or something of signal. So you have to, yeah, completely eliminate, yeah, like motion and stuff like that, or you need to have a very good algorithm to get pulse from that. But I think I will continue to try. It's just a first result. I didn't change anything in the algorithm or something. So yeah, maybe I will have some more results to share, which are a bit better once I tried it with some other lighting setup and stuff. So yeah, that's just a little contribution on how to do pulse extraction a bit differently from classical wearables, I think.
Thanks.
That's so cool.
Yeah, I also think so.
Do you think about like setting up a camera to just watch someone and be able to extract their pulse over time? Like,
yeah, I don't know if it's so practical. For the first, even after I got the results, I think it's not practical to do that because you always move or something. But it's just really interesting to see that it's possible. So yeah, it's just for my curiosity at first.
So a practical direction that it makes me think about is, you know, a situation where there's a camera pointing at your face a lot of the time is with eye tracking that's moving into VR headsets more and more, and saying if you can pick out from the eye tracking data your pulse, that'd probably be a really helpful feature. And a lot of game developers could use that API to make things more or less scary dynamically. But yeah,
yes. I had a different topic for discussion actually that that I thought, since Richard's here, I know Richard and Bastian were having some back and forth about notebooks and configuration stuff. And so since you're both here, and
that is exactly why I joined the call.
So, Rich, yeah, maybe Bastian can talk about like how, like whether we can update the Jupyter Hub stuff, or yeah, I know this gets into deep dive of tech stuff, but like the notebooks are really cool to be able to run stuff.
They are super cool. And I'm like a reasonably intelligent person. I'm not one of the greatest programmers on earth, but I figured if I can't figure out how to use this kind of out of the box, then we got to figure something. I'm happy to donate time to writing a nice little tutorial, whatever it takes, but it was just a lot of hair pulling, and I thought it'd be easier just to talk to Bastian at some point.
Yeah, so I think that what we really need to do is just update all the dependencies in the virtual machines. So the Docker file we've been using, I think it's like 2 years old. So that's how old the dependencies are. And that's why many of the things that you wanted to have are very outdated at this point. So I think we just need to sit down. By we, I mean probably me. I need to sit down and make a new image and a new Docker file.
Is that a lot of work, or is that just is it, you know, an hour's worth of work, or is it a day?
It depends. So it depends on the internet connection. I think that the biggest thing is that for actually doing the testing, you need to make the whole container thing, push it to Docker Hub, deploy it on the Jupyter Hub, and see whether still everything works or not. And the image, I think, is like, it's like around 10 gigabytes, I think, by now, the final image. So that's like just like you need to compile it, then it like you can go have a coffee, then you upload it, you can have another coffee, and then you see hopefully it works. And most likely it does not. So you like go back to step one, change dependencies, and go back to having coffee. So no, it's definitely manageable in terms of time. I think the one thing I'm a bit worried about is whether we can upgrade many of the dependencies without having to upgrade the Jupyter Hub itself. And then it would be a significant investment in time. Because
and
then
we've
it
just
means
discussed upgrading the Jupyter Hub itself in the context of Voila, is that right?
right. So I think let me write this down in my to-do list right now.
Well, and I don't want you necessarily to do it on just for little old me, but
no, it's not, because Voila is really exciting, and we wanted to do that too. I don't know if you've seen Voila. It's like this thing where you don't see the code, so it's like a view into the notebook where you.
Oh yeah, I did see it. Yeah, I couldn't get to work. I'm using R, which is sometimes not a, it's not like Python or something that a lot of people are probably being in, but which might be part of my problem. But anyway, I still can't find a workaround. So actually, my workaround is to use that that way. I get the token, and then I go run it locally on my machine.
So you're making a note to reach out to Tim, maybe?
Yeah, I just made this now for reaching out to Tim to see whom we can hire for doing the whole upgrade. Because that's certainly beyond my Jupyter capabilities as well.
I'm trying to remember if he ever charged us before. I mean, it's like we can commit to paying and then he doesn't care. But Tim Head is a great expert in Jupyter Hub development, and so if he's
he helped us set up the whole thing, and he's one of the main contributors to Project Jupyter. So, and especially to Binder and the Binder Hub project. So if anyone knows how to get a working container, it should be him.
Yeah, that would be great. I know you have a lot of things.
Thanks. It'd be great. Yeah, it'd be great. I've got a bunch of things I wanted to play around with because I've got it working locally. It'd be very cool to have, like you say, I wanted to get that Voila feature working.
Yeah, but, I mean, like ultimately, I think once we do the upgrade, I know that it's very easy to get RStudio run in the Jupyter Hub. So you can just run RStudio in your browser. So like even people that prefer to use R and RStudio can do it right in the Jupyter Hub instead of having to do it locally.
Yeah, anyway, whatever you can do, you'll have at least one user, so.
Yay. That's a very good motivation because so far it has been largely Matt and me writing notebooks and we just use Python mostly, so.
It's not insignificant. It's actually really valuable. Even just one person who wants to make notebooks is creating something that a lot of people would be interested in, so.
And the cool part is when you've got the source code there, other people can copy and paste and whatever. It's just, it grows from there. I wanted to use your confinement measures rescue time thing.
Yeah.
But you keep track of your data slightly different than I do. So I needed to go and modify it and whatever. But I mean, it's great. It'd be even greater for me personally if it could be in the same updated version of R that I normally use.
Yeah, we'll get to it.
Thanks.
Thanks for taking the time and poking us to actually do it instead of having it like disappear on Slack. I appreciate it because I'm usually also the one poking people and I know that I need the same poking to actually get around doing things. So.
Well, I appreciate everything you do because it's just, I realize it's a lot of work but it's very cool when it's working.
Yeah, thanks so much.
I'm going to have to leave, but it doesn't mean the meeting has to end, and that's why I made Bastian host. So I'm going to say goodbye, but pass the ball to Bastian. I'll let you continue.
Wait. One thing is like the recording tied to me as well, or does the recording stop?
It looks like it moved to you.
Okay, great then.
But if not, this is goodbye for everyone on the recording.
Okay.
Bye.
Thanks, bye. And does anyone else have anything to share, anything we should talk about?
What are the Thursday meetings like? There's like a Thursday 10 o'clock?
So the Thursday meetings are for people who present their own little self-research projects. goes back to the Keating Memorial we started doing before the whole confinement coronavirus thing happened, but people present their own little research projects. So I think Gary already had to leave, unfortunately, as well, but he's doing one on tracking his tremor. Then we have people like Kate working on resting heart rate, and yeah, it's just people giving small updates on their own work. And we don't record those so people can more freely share. They are partially like very personal experiments, that's why. But yeah, you are happily invited to come along and just join and have a chat.
I'll make sure to join, yes.
Otherwise, I would say thanks everyone for joining, and hope to see many of you either on Thursday or next week again. Bye everyone.
Bye bye. Stay healthy.
You too.
You too.